All right, hello. So we're doing a video answer key for the Regents that we just practiced and took. So this is going over the June 2025 in preparation for the January exams. Okay. The format of the Regents is 24 multiple choice and 13 short response with a total of 37 questions altogether. But to pass the Regents, you need to get 24 questions correct, and that will give you a 65%. Okay. So the first time around, if you take it, get a 65, cool. You're in the game. You're winning. Okay. So we're gonna go ahead and get started. And we are going to go through every question, but we want to make sure that we understand how to do it. Okay. So this is a good first question because it gives us an opportunity for to figure out how to do some of the questions that come up a lot. And there's going to be at least two to some regions even have seven questions that are similar to this, and it's using the word equivalent or an equal sign. Or the word approximately equal can be rewritten as is the same as equivalent, right? These are all the same thing. They're synonyms, okay? So how do we do problems like this? What we do is we pick a random number. So whenever you see my video key, I'm always going to use 2.1, and we're going to take 2.1, we're going to store it into C, okay? So how do we do that? Let's go to our calculator, okay? So you see how we're going to press C. That's the variable that we're talking about. Whenever my calculator decides to function, that would be wonderful, okay? So I'm going to press C. And now I'm going to hit Control, and under delete, there's a little button that is a colon and an equal sign. So I need that. And then I'm going to put my 2.1 in. And now I said I'm going to do C. Let's try that again. C, Control, right? Colon, equal 2.1. And I'm going to hit enter. Okay, so now whenever my calculator sees a C, it's going to plug in 2.1. Okay, now how does that help me? I'm going to go back to my question. I'm going to plug in this original thing. So 2C times the cube root of C. Okay, so let's plug that in. 2C times the cube root. So control this little mountain thing. Okay, that allows me to put the 3. And then I'm going to go over here and I'm going to put my C. And I'm going to get an answer. So this answer is 5.37843. Okay, if your float is on, it might be a different number, but generally you'll get 5.38, 5.4, something like that. So I'm just going to go ahead and write that number down. So 5.3, what was it? 78. Okay, and we understand that there's more to this number, right? If I go up and I hit enter, that's what the whole thing is equal to. All right, cool. So now what I'm going to do is I'm going to plug in each of these other ones, and whichever gives me this target answer, 5.378, da 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 da, then that's the answer. Okay, so let's go ahead and start with our first one. So our first one says 2c to the 4/3 power. So let's plug that in. 2, oh, that's not c. 2c to the, which is the little mountain symbol. To get a fraction in the calculator, I hit Control Division. So I'm going to do 4/3. And if I get that answer, which I do, see that? So they are both the same thing. So this is also 5.378, which means that the answer choice that's correct is 1. So now I'm just going to show you another one. I'm just going to show you 2, and I'm going to show you why that is not the same. Okay, so I'm going to cheat a little bit. I'm going to go up here, hover over that. You see how it's blue? And I'm going to press enter to bring it down, or you could do Control V. This is like a computer. So I can put my 4 on the bottom. I can put my 3 on the top, because that's what I have, right? 2c to the 3/4. See that? So now when I hit enter, I should not get 5.37843, and I don't. Okay, so I know that 2 is wrong. And then you could go ahead and test the other ones. All right, so this question, I went ahead and did it already. It's a very pretty much straightforward question. This is asking you which one has cause and effect. And we know that we've done this since middle school. I think this is an experiment, okay? A census is a population count. Observational study is when you observe or when you look. And a survey, we've all done a survey before, okay? All right, question number 3. What is the solution? So remember how I said there's going to be multiple questions that are synonymous with the word equivalent, and equal sign is also equivalent. Okay, so how do I do this question? We can go ahead and do it the same way, right? See, plug in, we can look for a number that is equal to 50. This is going to be our output. So the one way to do this is to go ahead and go to our calculator. A couple of different ways. I could say, go ahead and say, okay, so I can say, okay, so they have different values of x, right? X is equal to this, or it's equal to this, right? So we're going to go ahead and take our first one. Let's just go in order. I'm going to take this number and plug it in for my variable. I'm going to plug it in for x, okay? So let's do that. Let's go back to this and let's type this in. So it says log. So log is control and then that button, the 10 to the x. So we have log and it says log of 50. Now, if there's no number on the bottom, you always just put a 10 when it comes to logs. Okay, that is a given. So log of 50. And then you see how it has over 19. So I can go ahead and put close parentheses and then hit control division. You see what it just did? And put the 19 at the bottom. And then I'm going to take this right here and I'm going to store this in. So control and that button, I'm going to store this in for X. Okay, and I'm going to hit enter. Oh, I should have put this first. Let me try that again. Let's go back. Okay, so X, and then I do control this and I hit enter. And so now what it did is it took log base 10 of 50 divided by 19 and it stored it in for X. Okay. So now I'm going to go ahead and type this in and see if it equals 50. So 5 times 2, close parentheses, let's go back. It says to the 19x. So to the 19x. And if I hit enter right now and I get 50, which I don't, then I know that this is not my correct answer, right? X is not equal to log base 50, log base 10 of 50 divided by 19. Okay, so now I'm going to plug in the second one. Let's try this. So X is equal to log base 2 of 10 divided by 19. So I'm going to go up here. I don't want to type this all over again. So it was log base 2 of 10 divided by 19. Cool. And because I already typed this in, I can just go up and grab it. And if I hit enter and it's 50, there we go. Cool. So I know that the answer is log base 2 of 10 divided by 19. So it's choice 2. Okay. And you can do the same thing and show that 3 and 4 did not work. Okay. All right. So this one, we did do a question like this, right? They give us a function. And then they are telling us which statement is not. Key thing here is which statement is not true. Okay. So if I take a look at this, the first thing that I'm noticing is that in my parentheses, this is a number that is less than 1, which means that it is a decay. All right. So now how do I find out what my decay rate is, right? Remember our formula is A 1 minus R to the T, right? Or some people put like the P is here. So A is equal to P, parentheses 1 minus R to the T. So let's figure out, since we know it's a decay, let's do 1 minus, and then let's put this number in. So 1 minus 0.965, and that will give us the how much it's decreased by. So let's do that. 1 minus 0.965. And when I hit enter, I get 0.035. Okay. So this answer is 0.035. Now, what is that as a percent? Right? To figure out what that is as a percent, we're going to move the decimal 2 places to the right. So from decimal to percent is 2 places to the right. So this is 3.5%. That's the rate of decay. So our rate is 3.5%. Now, automatically, this right here says the decay rate was 0.35%. That's not right. It's supposed to be 3.5%. They moved the decimal incorrectly, right? They multiplied only by 10, not by 100. So this statement is not true. So now let's take a look at the rest and just make sure, right? The estimated a function estimated the population in 1999 was 256,485. This is true because this is our start. That's our start amount. So that is a true statement. The decay factor is 0.965. That's not true, right? The decay factor is going to be 1 minus the rate, right? So that is 0.035, which we said is 3.5%. So that statement right there, this is the decay factor is 0.965. Okay. The decay rate is 0.035, which is 3.5%. And then the next one, the population declined over 15 years. That statement, it says from 1999 to 2014, right? So 2014 minus 1999. 1999 is 15, so that is also a true statement, okay? So 1, 3, and 4 are true statements. It's asking us for which one is not true. The decay rate is supposed to be 3.5%, not 0.35%, okay? All right, the next one. So we did not do a question like this. So technically, you could not do this. So on this question, since we didn't do a question like this, you can just go ahead and guess. For those of you that want to know, the correct answer is 2, Chris. Okay. This one. So look, is equivalent to, right? So now we know that we could take these and we can plug this into the calculator. So we have a is I to the third. So let's go to our calculator. Let's start defining stuff. So I'm just going to go ahead and hit a new one just so I don't double up on variables. Okay. So it said a was I to the third. So what am I going to do, right? I'm going to do a control, right? The colon equals I to the third. So I is where pi is, okay? So I'm going to go over here, I to the third. So now my calculator knows that a is I to the third. Then we're going to do b, right? So we're going to define b, control, right? The colon equal, and we're going to say I squared. So again, I is where pi is. So I squared, and I'm going to hit enter. And then C is equal to I. So we're going to do C, control, right? And C is I. Again, I is where pi is. Hope you get sick of me saying that, because I am. Okay, cool. So then it's saying, which expression is equivalent to? So we have our A, we have our B, we have our C, but we don't have our X. So let's go ahead and define X as well. So we're going to say 2.1. Oh, I keep forgetting. It was on the other calculator. I had to put the number first. So we're going to say X control is 2.1. All right. So now we've defined our 4 variables. So now we're going to go back and we're going to type in our original. Okay. So 2A, and you see how it's bold? That means that it knows that it's representing a variable. So 2A x squared. So now why did it take that out? Let's see. I think I might need to do, there we go, 2. Let's do the times. So 2 times x and then squared. We want to keep those bold, okay? Cool. And then we're going to put the plus sign, and then it's going to be 3b, and again it's bold, times x. We're going to follow the same pattern. We want to keep this bolded, okay? This should be in bold. And then we're going to do minus c x, but c times x, and we're going to hit enter. Okay, so now this is our answer, right? Negative 6.3 times negative 6.3 minus 10.92i. And just like before, we're going to plug in each of these ones and see which one gives us that answer. Okay, so you could plug in each of them. I'm going to type in the first one, so negative. So remember the negative sign is here. So negative 2i x squared. We have to do times x squared. Cool. minus 3x, and then plus I x, and we're going to hit enter, and that does not give us the same thing. Okay, so you'll see that when we plug in the third one, I'm going to try to keep this video short, but when you plug in the third one, and I want to show you that we're going to do this, I times x squared minus 3x, cool, minus I x, and we hit enter, and you see how they give you the same thing, right? So this is the same thing as this, so that means that my answer choice is going to be 3. Okay, all right, pretty straightforward. Common ratio, we did do this. Okay, so ratio, remember, is the number that you multiply by to get to the next one. So to figure out which one has a common ratio, what we could do, as it's not cheating, but we know that the opposite of multiplication is division. So we can take the second one and divide it by the first one and see if it gives us 1/2. Okay, so negative 1/8 a. Let's see if I could do this straight. Negative control division 1. Why isn't it writing? Oh, because I'm not there. Let's try that again. Negative control division 1 over 8. No, let me see if it'll let me put a. Okay, because it has a stored from before. Cool. And then I want to divide that by, I should put this in parentheses. Yes. Let's go. Divided by, and then parentheses again. So now I'm going to divide it by the first one, which is negative 1/4 a. So negative control division 1 over 4. Go to the right, a. And if I hit enter and I get 1/2, that is the answer. And it is. Look at that. So the correct answer is 1. Okay. And again, if you plug in each of the other ones, 1/16a divided by 1 over 32a, that will not give you 1/2. So that is not the answer. So on and so forth. Okay. Cool. So for this one, we did do a question like this. Okay. So I think the first part in any, when we were doing a question, you need to make sure that you've learned it in units 1 through 4. And this question we have learned, and specifically we learned it by using the remainder theorem. So remainder theorem says, and the reason how I know I can use remainder theorem is because all of these numbers, the remainders, are different. So I can use the remainder theorem. If it wasn't, I would have to do long division. Okay. All right. Remainder theorem says you take whatever you're trying to see if it's divisible, which in this case is x plus 1, and we're going to set it equal to 0. So -1, and we get x is equal to -1. Okay, cool. So now we're going to take -1, we're going to store it into x. So let's do that, right? So we're going to do -1. No, I keep doing this. Ah! We're going to do x control, right? Is -1. And I'm going to hit enter. Cool. Now I'm going to plug in the original, like this whole thing. So I'm going to see what that is equal to. So 2x, what is it, to the third? That's a square. Let's go back to the third. So this just teaches us to be careful as we're plugging in. Plus 6x squared plus 7x plus 2. So this answer, see how it's -1? That means that the remainder has to be -1. So which one has a remainder of -1? Right? This one has a remainder of 17. This one has a remainder of -13. This one has a remainder of -1, which means that that is the answer. And again, that's called remainder theorem. Okay. Cool. We did not do a probability question. So far right now, the first 8 questions we were able to do. Look, so out of 14, right now, right, out of 14 questions, we have already, as of right here, been able to do 8 out of the 14. We are looking good, okay? 6 more and we should be good to go. All right, so we're not going to be able to do every question, but let's do the ones that we can do, okay? All right, question number 10. So we have an f of x and we have a g of x, okay? This is a table, right? Here we have a table and here we have a solution, well, a function, okay? So it says which statement or statements must be true, right? Based on the information given. Both f of x and g of x have the same x-intercepts, okay? So same x-intercepts means that you have the y is equal to 0, okay? So here's our x, these are our x's, and this is our y's. Which one has y's equal to 0? -3 and 2. So what are the x-intercepts of g of x? G of x have x-intercepts of -3 and +2. So now let's see, right? Let's see the other one. So we have to go to our function. We're not going to open up a new graph, right? Add graph, cool. And we're going to type in our function, which is parentheses. It's x minus 2, close parentheses. Ooh, it did it twice. Okay, let's do this correctly. So x minus 2 squared, and then x plus 3 in parentheses. So parentheses x plus 3. All right, now I'm going to hit enter. So now what it does is it graphs it, okay? So now I can see that my intercept here is at, right? That look number right there is 2, and -3 also. And we can verify that by hitting menu, going to our table, split screen, and looking at our, right? So across from 2 is 0. And let's check that -3. Yeah, across from -3 is also 0. So that statement right there is definitely true, okay? So 1 is true. That means that this is wrong and this is wrong. So now let's see if the second one is true. Both f of x and g of x have a y-intercept at y equals 0, which means that we're looking for where x is equal to 0. So here, this is our y-intercept. Okay, so that's correct, right? So g of x has a y-intercept at y equals -6. Let's check our calculator to see, is across from 0, do you see -6 there? I don't. I see 12. Okay, so we know that this is not true. That means that only 1 is true. Okay. Cool. So right now we've done 9 out of 14 questions. We're going to aim for more than 14, but you get the point. All right. So Josie examines the graphs. So cool. As soon as we see that, we're going to open up a new graph. I just want to say something real quick. If you hit on and you hit this little graph button, it'll open up a new one. That is true. But you might have other tabs stored at the top, which might confuse you. So I just open up a new one every time I'm doing it. Okay. Question number 11 we can do. So we're going to go ahead and type in 3 to the x minus 8. So 3 to the x, then go to the right, minus 8, right? Look where the minus 8 is. And I'm going to hit enter. And then we're going to go ahead and plug in the other one. So menu, there's probably an easier way to do this. Sure. We're going to type in under F2, we're going to type in the second function, which is control division. So it's 1 over x squared minus 4. X squared minus 4. Okay. So we have two funky looking graphs and we're looking to see the number of solutions. The number of solutions. How many of them are there? Okay. So right now I can definitely see 2, right? I see 1 here. Okay. And I see another one over here. But I don't see the whole graph. I want to zoom a little bit out. So let's do that. So let's zoom out to make sure that we can see the whole thing. And the calculator is going to be like, where do you want me to zoom? Let's go right to the center. Boom. As soon as I do that, don't you see 3? I see one intersection right here. Oh, it's going to keep zooming. Another intersection uh, over here, and the last one somewhere over here. So there are 3 of them. If I wanted to find it, which you could definitely do, let me change my zoom back to in. Let's see. Okay. So if you wanted to find the points of intersection, you could hit menu, you could hit analyze graph and intersection, and then you can go anywhere to the left of where they intersect, and you can press the mouse key and you see how it opens up the little gray. So we can go to where a little bit past where they intersect and let go of it, and it gives me, see, right there is the point of intersection, negative 1.97. So that's if it asks you what are the points of intersection. This one just says how many there are, and there are 3 of them. 1, 2, and 3. Okay, so let's answer that. That's 3 points of intersection. Cool. So that's 10 out of 14 questions, and we're only on number 11. Yeah, let's go. Okay, which binomial is a factor? So remember what factors mean, right? Factors have remainders of 0. Remainders of 0. So low key, this is another remainder theorem question, right? Set this equal to 0. So we get g is equal to 1. So we're going to store 1 in for g. So let's go back. Tudunt, tudunt, tudunt. Okay, so I'm going to do g now. Control, right? That button. So I'm going to store 1 in, and then I'm going to plug in the function. So the function says g to the third, cool, plus, oh, you see where I put my plus sign? Barkeys, pay attention, girl. Plus 6g squared, so 6g squared plus g minus 14. Okay, and I'm going to hit enter. If I get 0 here, there's my answer. I don't. Of course not. All right, so now I want to go to the next one. Okay, so I know it's not 1. Let's plug this equal to 0, and I get g is equal to 2. So watch, I can just go up here. I can grab this, change my 1 to a 2. Cool. I can go up and grab this baby. I said this baby. Hit enter, and if I get 0, I'm done. Oh, man. Okay, so this, I'm not done yet. Let's set this equal to 0, so I know that g is equal to negative 1. Hopefully this is it. So now I can go up and grab this, change that to negative 1, hit enter. I'm going to use as many calculator tricks as I can. That's not it. So it has to be the last one, but let's just verify. So g is equal to negative, too fast. G is equal to negative 2. So let's go up, change that to negative 2, hit enter. This better give me 0. There you go. Okay, so our answer is choice 4. That way, that time it made me work for it. All right, cool. So that's 11 out of 14 questions. Let's go. Okay, this one. So this is a sequence. It's telling us that the first term is 8. And then to get the next term, an, you're going to do 2 times an minus 1. So 2 times, this is, right, the first term. So 2 times the previous term is 16. Then I'm going to multiply by 2 again. That's 32, 64. So it says, which explicit formula represents the same sequence? Okay, so let's do it. Explicit formula means I have 2 to the first, 2 to the second, and I'm going to see if that matches. 2 to the first is not 8, so that's wrong. Okay, now let's try the next one. 2 times 4 to the first, that is 8. 2 times 4 to the second, is that 16? No, because 4 to the second is already 16. Times 2 is 32. That's not the same thing as 8, 16, 32, so that's wrong. Cool. So then this one automatically I know is wrong because 8 to the first is 8 and then 8 to the second is 64. That's not what I have. So it has to be choice 3, but let's check that. 2 to the n plus 1. So 1 plus 2 is 3. And 2 to the, what am I doing? Girl. 2 to the 1 plus 2 is the same thing as 2 to the third. So yeah, 2 to the third is 16. That works. And then if I do the next number, 2 to the 2 plus 4, 2 plus 2, Vargies, stop brushing. And that is equal to 2 to the fourth. Is this 2 to the fourth? Yes. And then if I do 2 to the 3 plus 2, does that give me the same thing as 32? 2 to the fifth is 32. That works. That better have worked, otherwise I would have been lost. Okay. So which one is the same? All right. This one, we did not do this question, but this is an easy one. Can I show you? Of course I can, because you have no choice to respond back. This is a video. So I'm going to do 2 times, right? This right here, negative 5 pi over 6. I want to make sure my mode is in radian. So I'm going to type that in. And now I'm going to hit find tangent of this value. So tangent is trig. I'm going to go to tan. Cool. Let's get out of that. And then here I'm going to do negative 5 pi over 6. So control division for my fraction. Negative 5 pi is over here. What did I do? I did something. Negative 5 pi over, what was it, 6? Cool. And I'm going to hit enter. And now I need to see which of those answer choices gives me the same thing. So I'm going to plug in the first one, control division. I'm going to type in 1 over radical 3, square root of 3. And that, look, that gives me the same thing. So the answer choice 1. So only new thing here is if it says pi, it has to be in radian. If it said like 35 degrees, that would be in degrees. Okay, so you just have to change that mode. But like I said, we didn't do this, so technically I'm not going to count it. So how many questions is this? This is 12 out of 14 right now. I'm not counting question number 14. All right, this one. What is n in terms of m? Okay, so technically, have we done this? No, but you have enough skills from Algebra 1 to do this question. I'm going to push you a little bit. Okay, so this is 17 to the 1 over m times n. This is called a power to a power, which means that whenever you have a power, you multiply it by the other one. And that combines those two. So we have 1 over m times n over 1. How do we multiply fractions? Top, top, bottom, bottom. So that's n over m. Okay. So this says 17 to the m over n is equal to 17 to the second power. So now it's saying, what is n in terms of m? Okay. So since our base is here, do you see how these two numbers are both 17? So you can cancel them out. So what we really have, I wrote m over 2. This is supposed to be n over m. Okay. So now what I really have is n over m is equal to 2. They want me to get the n by itself. How do I do that? This is dividing by 2. To get rid of dividing, this is dividing by m. To get rid of dividing by m, I'm going to multiply both sides by m. So these cancel out. So I get n is equal to 2m. And that is there. Okay. So like I said, technically you could have done this because you know from Algebra 1. Should I count it? I don't know. You have to decide there. I would say I'm going to count this as 13 over 14, even though I don't need to, because we would have our, we would be okay. This is also another one. Technically, you could do this. So once you read the question, it says he's won 8 out of the 10 matches that he has played. Which equation can be used to determine how many more consecutive matches or X? So we're looking for, if I keep looking at this question, it says must win in order for his winning percentage to equal 90%. This makes me think of like the mean, like you're looking for, there's 8 games that he's already won, right? Plus another game. We don't know how many of those X's we have, but it says how many more consecutive matches X. So we don't know what that value is. It could be 2 more games, 3 more games. And then you're going to divide that by the total, which is currently right now he's played 8 of the 10. So he's won 8 out of the 10. And then if he consecutively wins these right here, the X, that's going to give him 90%, right? So far right now, we have to find something that is equivalent to this. Uh, that doesn't have the 10 plus X on the bottom. This doesn't have the 8 plus X on the top. This has 8 over 10 plus X. That is not the same thing. So the only one that matches is choice 4. Okay. Like I said, technically, I am not going to count that because this is a problem. It's more like a reading question. So remember Polya's, right? Read the problem, come up with a strategy or a plan, execute the plan, and then see if your answer makes sense. Hopefully, you could follow that protocol and be able to eliminate at least 2 choices that are incorrect. Okay. All right. For this one, is a calculator question. Okay. So for this question, we did do a problem like this, but this is called like a 3 by 3 variables. Usually, we have X, Y, and Z. So we do have X, Y here, we have a Z here. So this is still 3 equations and 3 variables. So how do we put that into the calculator? For sake of time, I did plug this in already, but let me show you how we get there. So over here. So how do we get to where we can plug this into the calculator using LinSolve, right? You go menu, we are in Algebra, and this is solving systems of linear equations. So here you're going to change this to 3. And when you hit tab, you're going to see X, Y, and Z. Okay. And then you're going to go ahead and enter in your function just like this. Okay. You're going to enter that in and you're going to hit enter. And it's going to give you that your variables in order are 1, X is 1, Y is -1, and Z is 4. So let's write that down. X equals 1, Y is -1, and Z is 4. So now it says, what is the value of X? Boom. Shakalaka. X is 1. Okay, cool. So, let me count that, baby, right? So that is technically 14 questions out of 14. So with number 17, we have hit our 14 questions out of 14, but we are not going to stop. We are going to keep going, okay? So let's keep going. So for this one, we have not done this yet in Algebra 2. There is a lot of Algebra 1 here. So for this one, it tells us the point 2, -3 lies on the graph. So the first number is our X, the second number is our Y. And it's going to say which point must lie on the graph of the equation. And so what they did is they took our X, the X value, and they subtracted 4 from it. So we're going to do that, right? 2 minus 4, right? So this one right here, when we do that, when we get a shift, it has to be a negative negative. So 2 minus -4. And then for our Y, it says we're just going to leave that one. So that's going to be, we're going to take our Y value, and then, which is -3, and we're going to add 1 to it. That's what our new coordinate is going to be. So this X minus 4 means it gets shifted to the right. And when you're doing that, you're going to do 2 gets shifted to the right, 4. So 2 plus 4 is going to give us the 6. We are adding that together. And then up plus 1 means that the Y value is going to go up 1. Okay, so sorry if that was a little confusing. I'll do a better job in person on going through that, but let me know if you get stuck on that one. But 2 minus -4 is 6, and -3 plus 1 is 2. So our answer choice is 6, comma, -2. Okay. I think we already have our 14 out of 14, but I won't count that one. Okay, this one we did. Don't play with me. We did this, guys and girls. Okay, so how do we do this? So we're going to go back to our calculator. I always start a new one, add a graph now because we have a graph. So we're going to do log. Remember, if there's no base, the base is always 10. So it says log of x minus 3, x minus 3, and I'm going to hit enter. So this is the graph of log of x minus 3. So now what is happening to our graph, right? What's happening is that on the left-hand side, you see how over here it's approaching a certain number here, right? So as x goes closer to 3, if I can go ahead and just zoom out a little bit so we can maybe see what's happening in the whole graph. Zoom out. And I'll move it. You see what's happening here? So the graph gets very close to 3, but it doesn't go up past it. And if I keep zooming out, I'm going to show you. Watch. You see how if I keep zooming out, it doesn't get past 3. So as we go to the right, it's going to keep going, right? As we go closer, let's see which one says that. So as x goes to negative infinity, which means as we go to the left, what's happening here, right? As we go to the left, our y is going down towards negative infinity. So it looks like the graph stops there, but we learned for logs it actually keeps on going. So the true graph of this looks something like this. Let me see if I could draw this better. Looks something like this, like keeps going like this, comes up, and it goes like this. And this is where 3 is. So this is what the real graph is saying. Our calculator is actually lying to us when it says it stops there. That's not true. It keeps going. So this one says, as x goes towards negative infinity or to the left, y approaches negative infinity. So that is true. As we go to the left, y does go down. And as x goes to the right, as we go to the right, y is going towards positive infinity. That is not true because it doesn't go up like this, right? It just gets closer and closer to 3. Okay, so let's see what's happening there. So it's not that. This one says, as x approaches 3, right? As here's 0. As we get closer to 3, right? What is happening to our y? Our y is going down. You see that? So that is true. Okay. And as x goes to positive infinity, as we go right, our y is going up. That is also true. So looks like the answer choice is 2. This one says, as x approaches negative infinity as we go left, y is going down to 0. That's not true. As we're going to 3, y is going to 0. That's not true because it goes past that. Okay, so those are incorrect. So the only one that does make sense is this. Now let's see what's happening here, right? Let's see if it keeps going up because this one says y goes towards infinity. So let's look at our table and let's see what's actually happening here. So as we go, what does it say? As we go to the right, what's happening? So our numbers are starting to get bigger. There's 1. It's going to take us a while. You see that? It's going to 2. Let's see if it gets higher. There's a shorter way to do this. Can I just do this and change this? No. Let me hit menu. Table. Edit table settings. Okay, cool. So let's do our table step. Let's start it at like 6,000. And let's go by tens. Okay. Okay, so it does get bigger. Yeah, it goes past 3. It's what I said originally. It just gets there slow. You see how I'm already at 6,000 and it's just barely, like it's 3.8. Okay. So what's happening here is it does get bigger than 3, but it gets bigger slowly. Like eventually it gets bigger than 3. Okay. So for this one, as x approaches 3, our y does go down. That is true. And as x approaches infinity, or as we go to the right, our y is going up. So this all says as we go right, y is going up. But the only one that's true for the left-hand side is as x approaches 3, y goes towards negative infinity. It doesn't go lower than that. Okay. So number 19 we can do, so we can say that this is 15 out of 14 questions that we need to pass. Look, rewrite this model, right? This is another word for equivalent. Awesome. So we could do this the same way we did this before. Let's go ahead and do that. Now save. Cool. So let's take our, what do they call this? They call these t's. So we can say t, control, I'm going to use my 2.1, enter. And it says rewrite in model. So we're looking to see which one is the closest. So we're going to put this in, and we're going to see which of these answer choices gives us the number that is the closest to that. So let's go ahead and do that, right? 5835 point, what is it? 943 times 1.026, close to the t. Then we get an answer, and then we're going to see which one comes as close to that as possible. So 50, we have to type in each of them. So 5835.943, same number to start, parentheses. When I typed in choice 3, it gave me the one that was the closest to it. Well, you can go ahead and type that in. I don't think you need me to do that, but you're looking for the one that is the closest to 6159, right? So if you, can I just erase this real quick? If you go up here and you hit enter, that will be the full value, 6,159, and you have to actually write this down, 6,159 point, and then 14600, 14600, da 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 da, and you have to see which one gives you the closest answer, and that one is 3. I'm going to say that we can do this. We are number 20 right now. We're making good progress. Okay. This one here, this one is in the lesson. We call them identities. So you're looking to see which one is true. So you can use this with or equal to 0 for all real numbers. So you can do this using the calculator button. You could also do this algebraically and see which one is true. So it says which of these expressions are all equal to 0 for all real numbers. So if you're doing this in the calculator, you can go ahead and store in a number for x, store in a number for y, plug this whole thing in, see which one gives you 0. So the correct answer for this that does work is 1 and 3. And you can go ahead and do that, right? Store two different numbers in, one for x, one for y, plug this whole thing in, you'll get 0. And then number 3 also will get 0. So that is the correct one for that. I'm going to call this number 17 out of 14. Okay, so this one right here are solutions. We're looking to see which one has, do you hear my dog breathing like that? Sounds like she's having a heart attack. The equation equal 5x over 5 has what kind of solutions, right? So you look and see where these meet. So this is a graph question. So new, no, graphs. So we're going to type in this under y1, this under y2, or f1. So 1 over x minus 1 over 5. So control 1 over x. And then this is minus control division 1 over 5. Cool. I'm going to hit enter. And then the next one for f2 is x over 5. So control division x hello, it's an x over 5, enter. And what kind of solutions are they, right? So menu, we're going to do analyze graph, we're going to do intersection. So let's see, boom. So this number here, 1.79, that is, what kind of number is that, right? Is it real? Is it imaginary? It's not imaginary numbers because there's real solutions there. It's not no solutions. Is it rational or is it irrational? So we have to see what this number is. Let's see if it'll let me do this. If I get out of here, if I hit on and I go to my calculator and I type in my x, no, not going to give it to me. There has to be a way. There has to be a way. Can I see what that whole number is? Yes, no? Let me try a control copy. So copy, control C. And if I go here and control V it, 1.79. Okay, that does work. Okay, so it says let me see. So it says 1.79, but I don't believe it. So I'm going to do this question algebraically because we did do this technically. Okay, so how do we do this algebraically, you may ask? When my computer decides to act right, I will do it. Okay, so how we did this is you have to look and see. You have to get the denominators to be the same. The computer right now is bugging out. Okay, so what we have to do here is look for our lowest common denominator, which is 5x. So over here, this one has an x, so I need to multiply it by 5. Whatever I do to the bottom, I do to the top. This one has a 5, I need to multiply it by x. This one has a 5, I need to multiply it by x. We did this lesson around Halloween. Now when the denominators are the same, you can get rid of it. So we have 1 times 5, which is 5, minus 1 times x, is equal to x times x is x squared. Cool. So how do I set this? I have to set this equal to 0. So I'm going to add x and subtract 5. Add x and subtract 5. So this cancels out, and I'm left with x squared plus x minus 5 equals 0. Okay. So when I look at this right here, I can see that there are no two numbers that add to give you 1 and multiply to give you negative 5. So rational numbers are any number that can be written as a fraction. And irrational numbers are numbers like the square root of 2 or the square root of 3. They are numbers that keep on going with no pattern and they don't end. So you could do the quadratic formula here. So our A is 1, our B is 1, and our C is negative 5. So negative B plus or minus the square root of B squared minus 4AC all over 2A. So let's go ahead and do that. So negative 1 plus or minus the square root of B squared minus 4 times A times C all over 2A, or 2 times 1. This is negative 5. I was like, something's going on. Okay, so now I have negative 1 plus or minus the square root of, this is 21, all over 2 times 1. The square root of 21 is an irrational number, right? It's not going to give you a perfect square, so it is irrational solutions, okay? There has to be a way to do it in the calculator. I'm going to have to look at that later about how to figure out if that 1.79 that we got from here is rational or irrational, because it's not the full number. Like, it's not giving me the full number, so I have to figure out why that's happening. Ah, I think I knew. Let me see. I'm going to change my settings. I'm going to go to this and I'm going to change my float. Make this float. Hit enter. I'm going to also go to my graph, wherever that is. Donde? Okay. Let's go back to this. I'm going to hit menu. I'm going to go to settings. Look at me figuring this out. I'm going to do the float. Okay. And look, see, it's giving me no more numbers now, so I know that it's irrational. I knew I'd figured this out. Just give me some time, guys. All right. Whoo-wee. Question number 23 is equivalent to. So we could use our store button for this. So we can say 2.1, we can store that into X. 3.5, I can store that into Y. My dog is going crazy. All right. And then you can see which one matches for this for 23. So this is, you're going to see that choice 4 matches. I think we've done enough problems like this now. I am also going to count this. Did I stop counting? So 17, I would say that this is 18 questions out of 14 that we needed. And I'm going to call this definitely 19 because it's an equivalent question. So 19 out of 14. And number 24 we did. So we are doing this problem. So the focus is -2, 1, and the directrix is y equals 5. So the first thing that you need to do here is you need to graph that point, -2, comma 1. Okay, this is our focus. Okay, our directrix is y equals 5. So I'm going to go 2, 3, 4, and 5. I'm going to put my dotted line here at 5. Okay. So then now what we're going to do is we're going to look to see the point that's in the middle. So we have to find that point. What is the point that's in the middle between my coordinate, which is here at -2, 1, and 5. Between 1 and 5 is 4, so cut that in half, that's 2. So this is going to be, our vertex is going to be at -2, comma 3. So here's our vertex, -2, comma 3. Okay, and I did that visually. The next thing we need to do is we need to find our P, right? So our P is how much this distance was, and that is at 2. Cool. But we got to figure out if our parabola is opening up or down. So we know it has to be down. Our parabola has to be like this if that's our vertex, because it can never cross our directrix, right? That's like a shield. So it can never cross that line. So it's going to be P is equal to -2. So now we have to plug it into our formula. Our formula is y is equal to 1 over 4p x minus h squared plus k. There's another formula as well. So you're just going to go ahead and plug this into it. So we have y is equal to 1 over p is -2. So 4 times -2. X minus h, here's our h, here's our k. So x minus -2 squared plus k is 3. So now we have to see which one matches this. This is a plus sign. So this is x plus 2 squared plus 3. And then this is 1 over -8. So which of those answer choices matches that? So they all have x plus 2 squared. So let's get this on the other side. So -3 minus 3. So we have y minus 3. So automatically I know that it's not these two. Okay, so y minus 3 is equal to, do I know it's not those two? Let's do it. -1 over 8 x plus 2 squared. How do I get rid of this -1 over 8? Multiply it by -8. So that will allow this to cancel. Multiply this by -8. Okay, so then I have, this is x plus 2 squared is equal to -8 times y minus 3. And that is there as choice number 1. There we go. Okay, So this is 20 questions out of 14 right now that we have done so far. So I'm going to stop this video key right at an hour and make another one for part 2.